sure you're using a pencil because a pen is going to have to probably get erased and fixed and scaled, and this is a process. So we're going to graph based on transformations. And I said we're starting with a doozy because we have two horizontal pieces going on here. So if I have a horizontal compression and some sort of horizontal shift, I have to factor that out first. So 4 times the sine of 2, and then x minus, what happens to 2 pi over 3 if I divide out a 2? It becomes what? Just plain old pi over 3, correct. So what happened here was, and remember all things horizontal are backwards, including the order in which you would do things. This is initially a horizontal compression. Then everything is shifting right pi over 3 units. Okay? Now, here is like this is what I use for my Algebra 2 kids, so I'm going to use the same thing here. A sine of B x minus c plus d. That's the maximum kind of number of things that can be going on. Okay? Most importantly, what's your formula for your period? What is it? Do you remember this formula? Yeah. So your period is normally 2 pi. We know that for a sine curve. Your period is 2 pi, but when you have a horizontal stretch or compression, that's going to stretch out your sine curve or compress your sine curve, and therefore the period size is going to adjust accordingly. So this particular one, think about a sine parent graph having a period of 2 pi. You don't have to draw this necessarily. This one was a horizontal compression. So if I compress this in, what happened to the length of the period? Did it shorten or lengthen? Shorten. Hence the reason you plug in, if I kind of calculate my period as being 2 pi over my b value of 2, my period just shortened to being pi. That's because of the horizontal compression that occurred. Of course, we have that formula, so that helps us, but the period is pi. So this one, my first recommendation for scaling a graph is to take whatever your period is and divide it into fourths, mainly because each cycle has 4 critical points, or 4 critical intervals, I should say. You've got your first critical interval where it's increasing, your second critical interval back to a 0, your third critical interval down to the minimum, and your fourth critical interval kind of to the end of the cycle. So I always think when I'm scaling, I want to kind of count by whatever the period divided into 4 parts is going to be, so pi over 4. However, I did mention we're starting off with a doozy, because this one also has a shift. So if I count by pi's over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, and so on, when I have to shift and start the cycle pi over 3 units to the right, that's not going to be great if I counted by pi over 4. So this is about as ugly as it can get. My period divided into fourths kind of suggests maybe to count by pi over 4s. But because I have a shift by pi over 3, I want to count by something that's conducive to both of those. What would that be? Pi over 12. So pi over 12 is going to kind of cater to both of those, because this is the same as 4 pi over 12, and this is the same as 3 pi over 12. It only wants one period. I haven't shifted up or down, so I'm just going to make this my y-axis. What's my midline? Zero. The D, that's your shift up or shift down, that's your midline. D equals your midline. And so in this particular one, it's not written there, but you could assume it's a plus 0. So if my midline is at 0, then my graph is kind of oscillating above and below 0. So I'm just going to keep my x-axis right in the middle of all this. And then I'm going to count by pi over 12. So this is my 0. This is going to be 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12, which I can label pi over 2. 7 pi over 12, 8 pi over 12, 9, 10, 11, 12 pi over 12 would be pi. And now I've scaled it so it'll be conducive to my phase shift and also conducive to my period size. So to start my sine graph, I am shifting this pi over 3 units to the right. That's, like I said, that's 4 pi over 12. So 1, 2, 3, 4 pi over 12. My sine graph is going to start there. Now, my critical intervals are going to be every pi over 4, meaning I'm going to reach my maximum within pi over 4 units. And then I'm going to come back down and hit my 0 within pi over 4 units, which is the same as 3 pi over 12. So if I go over 1, 2, 3 pi over 12, that's when I should reach my maximum. And what level is that at? What's my amplitude? 4. So 1, 2, 3, 4. And then 3 pi over 12 later, I should come back to my 0, which is here. And then 3 pi over 12 later, I'm going to reach negative 4, which puts me off the graph. So if I ran out of graph space, I can go backwards, right? Where am I going to be when I go backwards 3 pi over 12 to get my minimum right here? Do we follow? So my sine graph, kind of the parent portion, and I'm running out of space, but I'll just do that, is right here. Because it started off of the y-axis, so we all see the parent picture, I kind of had to think backwards. So I went like this. Now, I could come up with the y-intercept, right? That's a pretty critical point. So how do you find a y-intercept? Set x equal to 0, right? So y equals 4 times the sine of 2, 0 minus pi over 3. That's going to be 4 times the sine of negative 2 pi over 3. Now let's think of that. Negative 2 pi over 3, what quadrant is that in? Third, correct, because this is negative 3 pi over 3. So is the sign positive or negative? Negative. And the reference angle is pi over 3. What's the sine of pi over 3? Radical 3 over 2. So this is going to be the 4 and the 2 is going to reduce to negative 2 root 3. So that's my y-intercept. Now, we don't have a calculator, so we don't know exactly where that is. But that's negative 2 times 1 point something. So I'm guessing it's going to be like negative 3 and something. The 4 here. It does. It reduced with the 2. It definitely matters. So it's negative 3 and change, which makes sense because when this wraps back around, that's going to be it. Jalen. The period is pi, which means that's the length of the cycle. Because I shifted it, because there's a shift as well. So the length of the cycle is still pi. It's just I shifted it pi over 3 to the right, so it's actually going to end pi over 3 units past pi. Okay? And that brings me to kind of my second thought process. Oftentimes I'll start these, and I think you should do the same, is where does your cycle start? Starts at, your shift is pi over 3. And it ends at that pi over 3 plus the period, which in this case is pi over 3 plus pi. And if we can kind of estimate here based on the fact that we ran out of space, if I, here's pi, if I count, and I'm counting by pi over 12, so I need 4 pi over 12, there's 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12. So this is ending, that kind of parent graph section is ending pi over 3 units past the pi, because it started pi over 3 units past the origin. So I always like for you guys to have your eye on where does my sine parent graph cycle image start based on the shift, and where does it end based on the period past the starting point. Stephen. Well, if they're like making points, yes. So let me give you a little, yes, if it's like that, absolutely, it can't be sharp. There can't be sharp points. But this section of the graph is concave up. We're going to talk about concavity this year. So this is like the bottom part of a parabola. And then right here, technically called a point of inflection because the concavity changes and now it's concave down. You see that? I don't know if kind of knowing that gives you an idea of, you know, this one's a little far out. No wonder my graph doesn't feel right. It's a little far. When you run out of space like this, no, I'm not going to get caught up. But if you think about that concavity and kind of making this the top half of a parabola and this the bottom half of a parabola, you shouldn't have any problem with the curvature. Questions? Like I said, that's about as tough as it gets because the shift is not jiving with the period, and so we have to kind of find that common denominator to find something nice to count by that's going to be conducive to both. And that's where I landed on the pi over 12. I think that's the hardest part. I don't know, maybe that varies person to person. But the amplitude here was 4. That's your A. So if we, I think you know that one, but I'll just write it. A is your amplitude. Your period we talked about, that's 2 pi over B. That in this particular case was just pi. And your phase shift was pi over 3. That's your C. So your C is your phase shift. Keep in mind, you don't know the C value if there's a B value that needs to be factored out. Don't look at this and tell me that my phase shift is 2 pi over 3 because it's not. Now, for the sake of checking as you're reminding yourself of how to do this and you're working on your skills, when we graph these on a calculator, what mode should we be in? Radians, because this is all radian pies in terms of pi. So math, nope, mode, get it in radians. Y equals, I'm just going to type it in, 4 times the sine 2x minus 2 pi over 3. Okay? Now, window. I'm going from 0 to pi plus pi over 3, right? Can we end ours pi over 3 units past pi? So if you want on your window, you can just type that exact thing in. 0 to pi plus pi over 3. I mean, if you want to figure out the number, you can. I don't want to count by ones on my x-axis either. Kind of make it like the way you thought you should do it to see if it all matches up. I'm going to count by pi's over 12. My y scale, negative 10 to 10, is fine because I'm technically going from negative 4 to 4 for my range. And that I can count by ones. But when you're in radians, you're probably not going to have your x-axis count by ones. Then things aren't going to look quite right. So here is our version. How do we feel about that? You like that? Second trace, I'm just curious what the y-intercept is. Oops. Negative 3.46. We thought it was negative 2 root 3. Negative 3.46, I'm guessing, is going to be negative 2 root 3. Here we are. Good? Okay, so critical points that you may have to label. The y-intercept, 0, negative 2 root 3. Maxes and mins, so this minimum is pi over 12, negative 4. Zeros, or kind of the moment where your graph crosses the midline, that's a critical point, and the midline here happens to also be a 0. So that's 1, 2, 3, 4 pi over 12, so that's pi over 3, comma 0. 1, 2, 3, 4 pi over 12, 5, 6, 7 pi over 12. Comma 4 is your maximum. 8, 9, 10 pi over 12, which is the same thing as 5 pi over 6, comma 0. 11 pi over 12, 12 pi over 12, 13 pi over 12, negative 4. And then 14 pi over 4, 15 pi over 4. No, I just did that wrong. 13 pi over 12, 14 pi over 12, 15 pi over 12, 16 pi over 12, which reduces to 4 pi over 3, comma 0. So at any point you may need to come up with critical points. And again, it all comes back. If you've scaled it right and you know you're counting by pi's over 12, that's a very easy process. Good? Any questions? Okay. Next one. Cosine. First things first, factor out your 4. Nathan Zorn, what's my value here going to be when I factor out the 4? Yep. Good. Okay. So let's find our period. Period equals 2 pi over the b value of 4. So that's going to be pi over 2. Now, like I said, if you want to figure out what to count by partially, split your period up into fourths. So when I split pi over 2 up into fourths, what's that? Pi over 8. Very good. Now my phase shift is pi over 4. That jives pretty well with pi over 8 already, right? So I don't have that non-conducive denominator situation that I had the last time. So I think counting by pi over 8 is fine because your phase shift is going to work okay with that. You with me? Okay. Now, the cosine cycle starts at, since we shifted pi over 4, where does this cosine cycle start? Negative pi over 4 because we shifted left pi over 4. So think about your cosine parent graph. It shifted, it normally starts at 0, it's shifted left pi over 4. So I'm starting at negative pi over 4, and that cycle, the one cycle, should end one period later, which is negative pi over 4 plus pi over 2, because our period is pi over 2. That's negative pi over 4 plus 2 pi over 4, which is, what's negative pi over 4 plus 2 pi over 4? 1 pi over 4. So it should start at negative pi over 4, and it should end at positive pi over 4. That's pretty symmetrical, right? Around the y-axis. So I would put your y-axis right down the middle. Since we're starting our cycle in equidistant to the left as we are from the right. Our midline is still 0, so we can put our x-axis right down the middle. And then we already decided we should count by pi's over 8. So 1 pi over 8, 2 pi over 8, which is going to be pi over 4, 3 pi over 8, 4 pi over 8, which is going to be pi over 2, and the same thing out. Now, you don't have to label every single hash mark, but I wanted to just show that we know we're counting by pi's over 8. So our cosine parent graph starts at a maximum. What is our maximum value here? 1/2. Now, I'm not about to cram this in, so I'm going to scale my y-axis accordingly so I can use the space. I'm just going to label this 1/2. And I'm starting that, therefore I'm starting at negative pi over 4, comma, 1/2. And I'm ending at positive pi over 4, 1/2. There's the start and end of my cycle. Cosines start at maximums or minimums, so those particular ones happen to be 2 maximums. So my minimum is going to be halfway in between. And because I counted by the pi over 8, halfway in between is pretty easy. It's right on the y-axis, and that's going to be at negative 1/2. And then between my maximum and my minimum, halfway between those, I should have a 0, which will go right here. And halfway between them on the other side, I should also have a 0. So that's a pretty narrow cosine curve. That's because our cosine graph got compressed horizontally by a factor of 4. So what normally takes 2 pi to complete as a period just got compressed by a factor of 4, and it's going to take 1/4 of that distance to complete. How are we doing with that? That's really one period. If we wanted to kind of keep going, again, because I counted properly, that 0 is 1 unit to the right, so I'm going to hit another 0 coming back over here. And I'm going to hit my minimum 1 more unit away. My minimum. You follow? How do you feel about this, Stephen? Good. I was just going to highlight the one cosine curve that we started with, but we all saw it happen. So the amplitude is what? 1/2. The period was pi over 2. The phase shift, I'm going to say left pi over 4, I should say. Or you could say negative pi over 4. That would work too. Any questions? Okay. Let's jump down to the last one here. It's got some absolute values around it, which we're going to ignore till the end. So our amplitude equals 3. We have no phase shift. Our B value is 2/3. Do we agree? B value is 2/3. Okay. So where does our cycle, well, let's do our period. Period equals 2 pi over 2/3. Complex fraction. So to clean this up, I'm going to keep, change, flip. Well, that works out nicely, right? Period's 3 pi. So my cycle starts at what? 0, because there was no phase shift. And it ends at 3 pi, the length of my period. Now when I'm counting here, and again, I'm going to put my y-axis mostly to the left, because I could have put it all the way to the left. I don't know why I didn't. Because I know I'm starting at 0 and ending the cycle at 3 pi. What's the midline? 0, so that can go right down the middle. Now, I want to cut my period into fourths. So I want to count by 3 pi over 4. Count by 3 pi, which of course anything's going to jive with your phase shift here because we don't have one. So I'm going to cut my period into fourths. Now, that doesn't mean I need to do 3 pi over 4, 6 pi over 4, 9 pi over 4, and I can do like every other line is 3 pi over 4 to really spread out the graph. Or I could do every third line. I could make, will that fit though? 3 pi over 4, 6 pi over 4, that's going to be a little short. So I'm going to just do every other. 3 pi over 4, 6 pi over 4, which I'll reduce in a minute, 9 pi over 4, and 12 pi over 4. So the 6 pi over 4 is going to reduce to 3 pi over 2. And the 12 pi over 4 is going to reduce to just 3 pi. So when I start my cosine cycle, which starts at a maximum at 0 as my x-coordinate, what's my y-coordinate? 3. I'll just keep this traditional. I'll call that 3. And it's going to end at 3 pi, also at a maximum. So that's kind of like why first of all, I like to go starts at, ends at. Because then I can go halfway in between those for the minimum. And now, because I've counted right, halfway in between is actually going to land on 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. It's going to land right on something that has a label in case I need those critical points. So that's going to be at -3. And then halfway between your min and your max is going to be your zeros. One at 9 pi over 4, the other at 3 pi over 4. So if you ever need to label all your critical points, it's done. That's why I focus so much on what we should count by, so that we're not spinning our head in circles trying to figure out what these midpoints are. Now, without the absolute value signs, that would look like this. What do the absolute value signs do to a number? Stephen? It's always positive, which means this portion that's currently negative is going to get reflected up. Yes? Does that make sense? So this that's at 3 pi over 2 -3 is going to go to 3 pi over 2 +3, and that actually will have bounced back. I'm just going to lightly erase this so we don't totally forget where it came from. And that is the graph of the absolute value of 3 times the cosine of 2x over 3. If I'm doing this on my calculator, and my window, I'm going to go from 0. By the way, my window, even though I typed in a pi, when I come back to it, it will be the decimal version of that. My scale, I'm going to count by 3 pi's over 4. Why not? Because that's what I did here. And then I'll just go -5 to 5. And there's our graph. Good? So you see I counted by 3 pi's over 4. 3 pi over 4, 6 pi over 4, 9 pi over 4, 12 pi over 4. Any questions? Last one. Why don't you try this on your own, so I can see where you get stuck. I want to hear about the 5 critical points as well. So write down your coordinates of your 5 critical points. And raise your hand when you think you're done, and I'll come take a peek. Okay. What's that? Does anybody have any questions before I start? You start evaluating. Any questions? Anyone get stuck anywhere? Or not that you know of? Okay. So let's first take a look at this one. I see an x-axis, a y-axis, starts at 0, ends at 2 pi. What is this? Whose is this? What is this? Is that what you're counting by? Okay. Because you took your period and divided it into fourths, which becomes pi over 2. It looks like you technically took your ends at and divided that by 4, which is fine because this one started at 0, but in case it doesn't, just take your period. So he's got critical point 0, 1/2, pi over 2, 0, pi negative 1/2, 3 pi over 2, 0, and 2 pi 1/2. Questions, comments, concerns? Liam. It's not. There is no phase shift. Down one. Do you see how that's vertical? You don't see why it's vertical? Oh, you do. Yeah. If it was horizontal, that would have to be in parentheses. But we're taking the cosine of just x. So actually nothing's happening horizontally. It's all vertical. It's a vertical compression, which he got based on his amplitude, and -1 would have shifted it down. So, do you see that you forgot to do that, Kyle? Okay. Now, quick fix, I think. If 0, 1/2 was shifted down 1, where would that be? -1/2? I'm just going to move his x-axis, which means I'm going to have to move his labels too. To here. And I think problem solved. Because every 4 units is -1/2, right? So 0, -1/2. This is technically -1. Pi over 2, -1. I'm going to label this pi over 2 up here. Pi, 3 pi over 2. So the -1. This is -1.5. This is -1. It's moving all of our y coordinates down 1. So I just moved his x-axis. You should also always label your midline. Y equals -1. Good? That was a quicker fix than we thought, huh, Kyle? Your homework is there at the bottom. There was mine, by the way, if you want to look at it.
Back now?
Yeah.
I just did scale mine to make it easier to see.
Gotcha.
I'm going to be doing that in the home for sure.